Hi Math 30s. This video is going to be the second part of lesson 1 in permutations and combinations. What happens with perms and coms is there's going to be certain questions that you'll always see. So the license plate question you have to know, and then there's always going to be one of these type questions that you will be tested on. So this is called a routes question. Okay, what's happening is these are cities. So P represents Pitland, this is Queensville, and this is St. Luke's. And then the last one down here is Rutherford. So if you live in Pitland and you need to get to St. Luke's, there's two different ways you could get there, right? If you're starting here, you could go this way, or you could go this way. So we're going to figure out the number of combinations that there would be if you go this direction. So we're going to set it up like we set up the previous example, and there's stages. If I said how many different ways can you get from P to Q, the answer is 2. You could go that road, or you could go this bottom road. So there's 2 different ways to get to Q. Once you're at Q, how many different ways can you get to S? There's 3 different roads, so there's 3 different ways. So to get from P to S, we're going to use the fundamental counting principle, and it's the number of choices in the first stage times the number of choices in the second stage. There's 6 ways that you can get from P to S going through Queensland, right? And if you needed to, you could trace it out. You could say, okay, I'm going to take the top road and the top road. That's 1 way. I'm going to take the top road and the middle, 2. Top road and bottom, 3. And then do the exact same for this road. Now we'll do the opposite. If you are in Pitland and you're still going to go to St. Luke's, but you're going to go through Rutherford. So again, here, this way. So to get to Rutherford from Pitland, there's 3 roads. You got 3 choices. Once you're in Rutherford, there's only 1 road to get to St. Luke's. The number of choices that you have, if you set it up as a fundamental counting principle, would be the first stage has 3 choices and the second stage has 1. So there's 3 different ways. And you could map it out really quickly. You could say, I'm going to take this top road, that's 1 way. I'm going to take the middle road, that's a 2nd way, and I'm going to take the 3rd road, that's a 3rd way. Then what happens is they could say how many routes are there from Pitland to St. Luke's total? Like how many routes were there? So this is what's called an OR question. So what I mean by OR is if you're in Pitland, you could go this way or you could go this way. If you have an OR question, OR always implies addition. So from here to here, we had 6 different ways. Going the other direction, we had 3 different ways. So there's 9 possible ways that starting at the letter P, you could get to the letter S. And then that just says that right here. So star that in. Any example involving OR in arrangements, you're going to add. Okay, numbers. So let's look at a numbers question. They're talking about a rural area, and it says when you move to this area, you get a phone number, right? And what happens is they're going to give you an area code. So just like for Edmonton, when you move to Edmonton, you don't know if you're going to be 780 or 587. Okay, so this is going to be an OR question. So somebody moves into this area, and one of the choices that they could be given is these 3 digits. So everybody would have that area code, 345, okay? Then it says followed by any 3 further digits. So 345 will be followed by any 3 further digits. You know that the digits are 0 through 9, so there's 10 digits that you could choose from. There's no restrictions because it said followed by any 3 further digits, so it could be 000 if I wanted. So how many choices of digits can go here? That's going to be 10. How many choices in the next stage? 10. And how many choices here? 10. that would give you 1,000, 10 times 10 times 10. There's 1,000 different numbers that can be made, starting with 3, 4, 5, and then having 3 additional numbers. Okay, so you might get that option, or some people will move in and they'll just randomly assign you, your area code is going to be 2, so that's what you start with, followed by one of the digits, 1 to 5, so after 2, you're going to have a digit from 1 to 5, so that's the restriction that they give us. There are 5 numbers that they could choose from, right? And then it says followed by any 3 further digits. So then 3 more further digits. There's no restrictions on those digits, so 10 numbers to choose from can go there, 10 can go here, and 10 can go here. If you multiply, right, don't multiply the area code in, but if you multiply the 5 times 10 times 10 times 10, you're going to get 5,000 different telephone numbers. And then because you could be assigned the first area code or the second area code, in this town, there would be 1,000 plus 5,000. There's 6,000 total numbers that they could be assigned, or different numbers that would exist, and nobody would have, no 2 people would have the same number. We're going to skip class example 7. I do that one in a separate video, and we're going to do class example 8. You need to star this one. This, like the routes question, you're going to see so many questions with words. So here's what they've done. What it says is consider the number of distinguishable 4-letter arrangements. So when you see 4-letter arrangements, that means 4 stages. And what we're going to do is they give us the word English, and they say how many different 4-letter arrangements can we make using only the letters in English. So A says any letter can be in any position. So you say, okay, they're asking for how many 4-letter words can be made, so 4 stages. There's no restrictions for A. You count up the number of letters in English, so 1, 2, 3, 4, 5, 6, 7. And then if there's no restrictions, you say, how many choices do I have to put a letter here? There's 7 choices, right? There's 7 letters. There's 7 possible letters I could put there. Once I place a letter, though, that letter's gone. I've got 6 letters here left to choose from. Then I'll have 5 letters. Then I will have 4 letters. You multiply this, and you get 840. So using just the letters in the word English, you could rearrange them in 840 different ways. Here's going to be a restriction. So you do the restriction, remember, first. It's still going to be the 4-letter word. Okay. The restriction is the first letter must be E. So you say, okay, this guy has to be an E. You look at the word English. How many E's are there? There's 1 E. So that's my only choice. I got to put that 1 E there. That E is gone. I've taken care of the restriction that they gave me. I have 6 letters left. Then I've got 5, and then I've got 4. So multiply the number of choices, and you would have 120 different 4-letter words could be made that all start with E. Okay, here's another one with restrictions, and we've got to take care of the restrictions first. So it says the first and the last letter must be vowels. So this guy and this guy has to be a vowel. You then go to your word English and you say how many vowels are there. So there's E and I. There's 2 vowels. So that first stage, I could put an E or I could put an I. So how many choices do I have in that first stage? I've got 2 choices. Then this letter has to be a vowel. There's only 1 choice left. If you placed a vowel here, you've only got 1 vowel left. That means that the consonants would be in the middle, and you'd say, okay, well, what number would you put for this stage? You had 7 letters in the word English, and you placed 2 of them, that leaves you with 5 letters and 4 letters. So then you multiply 2 times 5 times 4, and there's 40 different combinations or arrangements that you can make. D would be the standard of excellence, so you could star that one. What it says for D is the word must contain a G. So set up your number of stages. It has to have a G. So I'm going to place the G here. You look at the word English, there's only one G. So there's only one choice that can go there. And then you would have, there's 6, 5, and 4. If we multiply that, that's 120. Okay, the issue, you wouldn't be done here. And the reason why you wouldn't be done is the difference between D and B is B told you E had to be the first letter, right? This one said it just has to contain a G. It doesn't tell you where the G is. So the G could be here, or the G could be here, or the G could be here. So this is an or question. So the G could be in the first stage, or the G could be here. So again, there's only one G in the word English. There's, after you place that one, you've got 6 letters, 5 and 4, 120 different ways. Or the G could be at the third stage, 1G, 6, 5, 4, 120 different ways. Or the last possible combination is the G's in the last stage. So again, there's only one G, but then there's 6 remaining letters that I could choose to go there, 5 and 4. So 120. Because this is an or question, you're adding 120, 120, 120, 120, or 120 times 4, and you're getting 480. Okay, so the questions you want to practice, 6 through 9 you wouldn't have done, 10 ABC, 11, 13, 16, and 17. And if you look at the questions, like just to quickly show you. So number 8, there's your routes question, right? 3 different examples that you're figuring that out. You go to number 9, now the word is produce. So figure out how many letters there are, and they want, again, 4-letter words, so 4 stages. This is a numbers question. How many different 3-digit numbers? And there's restrictions. So do the restrictions first, and then you could finish.